In this video, you will learn how to write and simplify ratios and use ratio tables. A ratio is a comparison of two values. We'll start by looking at some basic examples based on colors of blocks. How many of each color are there? There are 5 red blocks, 8 yellow blocks, 5 blue blocks, and 1 green block. We will use these amounts to write some basic ratios. Example number 1, what is the ratio of red to yellow blocks? You're going to see that we can write it in 3 different ways. 5 colon 8, 5 to 8, and 5 over 8. You'll notice that all 3 of these have the 5 first and the 8 second. Also, all of them are read by saying 5 to 8. Example number 2. What is the ratio of yellow to red blocks? This is different from example 1, where you were asked the ratio of red to yellow blocks. We can write this ratio in the same way as we did for example number 1, but we flip the order. 8 to 5, 8 to 5, and 8 to 5. It does seem like we could simplify this like a fraction, since 8 is bigger than 5 and that's on top. It seems like we could change it to 1 3/5, but remember that a ratio is a comparison of two values. We cannot change it to a mixed number. It has to stay 8 to 5. Example number 3. What is the ratio of red to blue blocks? Since there are 5 reds and 5 blues, we can write it as 5 to 5. In a way that's similar to fractions, because both of these numbers are divisible by 5, we can simplify this ratio. We can write it as 1 to 1. But we don't want to simplify it any more than this, keeping in mind that a ratio is a comparison of two numbers. We have to still have two numbers to compare. So we leave it as 1 to 1. This means that no matter how big or small the group is, we would have a ratio of 1 to 1 red to blue blocks. So for every red block, we would have the same number of blue blocks. Example number 4. What is the ratio of green blocks to total blocks? This one is a little bit different. All of the other examples have been part-to-part ratios. That means part of the group compared to another part of the group. This time we are comparing part of the group to the total group. So first we have to add up the total blocks. So we can add up all the blocks, 5 plus 8 plus 5 plus 1, which is 19. And then we can write the ratios in 3 different ways. Green to total is 1 to 19. Another very common use for ratios is in recipes. We are going to look at a recipe for the best lemonade ever. Example number 5. What is the ratio of sugar to lemon juice? So looking at this recipe, I can see that the ingredients we need are 1.5 cups of lemon juice, 8 cups of water, and 2 cups of white sugar. This recipe makes 10 servings according to the recipe card. The ratio of sugar to lemon juice can be written as the amount of sugar that we need to the amount of lemon juice that we need. So that would be 2 to 1.5. What this ratio means is that for every 2 cups of sugar you pour into the recipe, you also need to add 1.5 cups of lemon juice. We're going to continue looking at this recipe to look at a ratio table. In this ratio table, you can see that the first column is completely filled in with the same values as the recipe card. 1.5 cups of lemon juice, 8 cups of water, and 2 cups of white sugar. But then there are some other values put in to the ratio table in the other columns. We have to figure out what the missing values are. So I can see from 8 to 16 cups of water, it's doubled, times 2. So that means we need to do the same math to the 1.5 and to the 2 in order to fill out the second column. 1.5 times 2 is 3, and 2 times 2 is 4. Now, like I said, this is double the original recipe. So if we wanted to make enough for 20 servings instead of just 10, we would have to double everything. We can't just double the lemon juice or just the water or just the sugar. Otherwise, the flavor will not be the same. So whenever you're doubling a recipe, you have to double all the measurements. Let's fill in the rest of the ratio table. I'm noticing another pattern here. To get from 2 cups of sugar to 8 cups of water, you could multiply by 4. And I see that it works in the double recipe too. 4 cups times 4 is 16. So that means to go from the amount of sugar you need to figure out the amount of water, you can take the sugar times 4. 8 cups of sugar times 4 would be 32 cups of water. If going from the amount of sugar to the amount of water is times 4, how do we go from the amount of water to the amount of sugar? We would have to do the opposite, divided by 4. And 4 cups of water divided by 4 is 1 cup of white sugar. It looks like for every 1 cup of white sugar, we need 4 cups of water. Now, how are we going to figure out what this third column is? If I have 1.5 cups of lemon juice in the original recipe, what do I need to do with that multiplication-wise to get 4.5 cups? Well, you might know, but if you don't know, you could divide. You could do 4.5 divided by 1.5. Just use a calculator. 4.5 divided by 1.5 is 3. So that means that we could multiply the original recipe by 3 to get this third column. 8 cups of water times 3 is 24 cups, and 2 cups of white sugar times 3 is 6 cups. There are several ways you could figure out the last 2 boxes. Look for patterns. How do you get from 8 to 32? Or from 8 to 4? Or from 16 to 32? Or from 16 to 4? Or from 2 cups of sugar to 8 cups? Or from 2 cups to 1 cup? There are lots of ways that you could do this. So it's time to pause the video and take a moment to try to figure out what the last 2 boxes should be. The answer will be shown soon. Go ahead and pause it. How did you do? Did you come up with the right amount of lemon juice? The fourth column should be 4 times the original recipe, 6 cups of lemon juice. The last column is only half of the original recipe, 0.75 or 3/4 of a cup of lemon juice. Now you should know how to write and simplify ratios and use ratio tables. Thanks for watching.